All right, today we are moving on to comparing and ordering fractions. And again, remembering that our big idea is knowing what numbers mean helps us to compare things and solve problems, should be added there. And solve problems, there we go. So today we are working on comparing and ordering fractions. There's a number of different strategies that can be used for comparing and ordering fractions. We'll talk about a number of them today. All right, let's start and take a quick look at our first question here. I have 3/4 of a dollar, so 3/4 as a fraction. And I have 3/5 of a dollar. Who has more? How do you know? Turn and talk to your elbow partners. Press pause and turn and talk to your elbow partners. Any thoughts on which one of those fractions is larger and why you think so? All right, so which fraction did you say was larger? If you said 3/4, you would be correct. The reason being here that we have one item that again we get 3 parts of, and it's divided only into fourths. And remember, when we divide for fractions, we want our pieces to be equal sizes. So we have 3 items here. Now if I was comparing that same amount, which is a dollar, but now I'm dividing it into fifths, I'm going to try my best here to get them into equal fifths. As you can see, my parts are a little bit smaller, and 3 then, shaded in, would be a smaller amount. There's a smaller section of this one shaded in as there is of this one. As you can see, this one, 3/4 would make it up to this point. So that's one way of comparing and ordering fractions. That's called using strips or paper strips, whatever strategy you want to, whatever you want to call it, but strips is kind of the big idea. The main point when you are using strips is that those pieces have to be the same size. The other thing you could think about is perhaps thinking about your fractions in sets. So if I have 4 cookies and she has 5 cookies, and I get to keep 3 of mine, and she gets to keep 3 of hers, well, she's really giving away more. I'm giving away less, so my fraction is larger. That might help too, like thinking about it in sets. All right, so let's go along and we're going to do some practice together and look at some specific examples. All right, so we are going to look at 4 different strategies for comparing and ordering fractions. Our first one is strips, which we've talked about a little bit already. There's some criteria when you are creating your strips that have to make sure to happen. So here they're actually folding and measuring paper strips, and you can definitely use actual paper strips. Some students have found that they just prefer to draw their strips, and that's okay too. In order to use strips, you need to make sure that your strips are the same length, okay? Same size. As you can see, all of these strips are the same size, but this one has to be divided into 3/4. So that means it has to be 4 equal sized pieces. This one has to be divided into 3/5 or into fifths. So that means 5 equal sized pieces. This one would have to be divided into eighths, 8 equal sized pieces. So you might want to use your ruler and decide how long your paper strips are going to be that way. But it's really a little tricky to make sure that you divide them as equally as possible, because remember, those pieces need to be equal in size. These fourths are all the same size. I could not have this drawn like this and say that these are equal fourths, because this one is a whole lot bigger, and then that strip does not work. The other thing that's important, of course, is remembering that all of those strips need to be the same length to begin with. So a couple of those things that you need to make sure you're remembering when you are working with strips of paper. But as you can see here, they've done this correctly. All of the strips are the same length. They have them in equal divided parts. And here 3/4, so we take our fourths and we color in 3 of them. And here we take our fifths and we color in 3 of them. And here we take 5/8 and we color in 5 of them, sorry. And now we see which is the smallest fraction? Well, that would be this one because it has the least shaded in. So 3/5 is our smallest fraction. 5/8 has the next most colored in part, so it's our middle fraction. And 3/4 has the most colored in, so it is our largest fraction. Strips work really quite well, especially when you are comparing 3 or more fractions. Works really well. It's a good strategy to use when it's more than just 2 fractions that you're looking at. Let's take a look at the next strategy, and these are called fraction circles. And again, it's the same idea as the fraction strips in that the circles are the same size, and then they're just divided accordingly. So for example, here we have 3/4, so we need to divide it into 4 equal pieces. Now this is the hard part about circles sometimes, is getting those pieces to be the exact same size. So you have to really watch when you're drawing your circles. Here we have another one that's going to be 5/8. Eighths, again, you need to make sure you're dividing your fraction circle so that all your pieces are as equal as possible. And then do the shading in and see which fraction circle has more colored in. That works quite well. The key there being if you are able to draw circles with equal pieces. Not so bad when your circles are even numbers, but often circles and trying to divide them when they're odd numbers can be really tricky. So that would be thirds. Fifths is really tough to do in a circle. Yeah, see, I can't even do it. All of those part pieces aren't the same size. So I would hesitate to use circles if it's an odd number because it makes it a lot trickier to divide. When it's an even number, it's not so hard. So for 6, for example, I'm going to take it, cut it in half, and then I know I have to have equal sized pieces. So there we go. That's not so bad. Okay, so that would be fraction circles. The last one, no, not the last one. The second last one is number lines. And with number lines, sometimes a benchmark is helpful. And a benchmark is, okay, so is this closer to, benchmark, can't see my K there very well. Is this closer to 0? Is this closer to half? Or is this closer to 1 is part of what we generally consider when we're comparing them on a number line. Okay, so again, you're going to draw one line. Some students like to do this kind of like fraction strips and have a number of lines on there, which is okay too. When you're drawing your number line, we want to put on there here 1/2, 3/4, 1/4, and 5/8. So I'm going to have to divide my line into my biggest sections here. So I've got 8. So I'm going to divide this line into 8 sections. So I've got a half. Then in each half I have 4. And those sections, again, just like the number strips, need to be equal in size. Okay. So I'm going to start with 1/4. And now I'm just going to ignore every second. I'm going to take this and I'm going to divide it into 4 equal pieces. And then this, of course, being the 0, so that would make this the 1/4 line. This would be 2/4, this would be 3/4. So I can easily put now my fourths on there. So 3/4 and 1/4 are on there. 1/2 is not too bad because I know it's just half of that. And 5/8 is my trickiest one. I'm now going to have to count all of my eighths. 1, 2, 3, 4, 5. So 5/8. So now I can look at this and compare to see which fractions are smaller and which fractions are larger. So I can see that 1/4 is my smallest fraction, 1/2 is my middle fraction, 5/8 is larger, and 3/4 is the biggest. Using benchmarks to help me, I could see, okay, 1/4 is definitely closest to 0. 1/2, well, is really close to half. Benchmarks gets tricky when it's 5/8 and 3/4 because it's hard to sometimes know which one is closer to the 1 benchmark. So at that point you might need to really draw out your line very carefully and look at those two carefully. So that would be number lines, and with the addition of using benchmarks a little bit to assist you. And the last strategy, which works really well when there's only two fractions, is equivalent fractions. So this builds on what we did last day, is to list the equivalent fractions or find the equivalent fractions for 2/3 and 3/5. All right, so here they're listing all the equivalent fractions, which works quite well. So 2/3, oops, sorry, let me get rid of that little box. 2/3 is equivalent to 4/6. I've multiplied by 2. Now I go back to my original fraction, 2/3, and I multiply both by 3. So I'm not continuing to work with the 4/6. I'm going back to my original fraction. And now I'm going to multiply by 3 for the top and the bottom. 2 times 3 is 6. 3 times 3 is 9. And then I can look at 8/12, or 4 multiplying by 4. 2 times 4 is 8. 3 times 4 is 12. 2 times 5 is 10. 3 times 5 is 15. 2 times 6 is 12. 3 times 6 is 18, and so on. And then I'm going to do the same thing with 3/5. 3 times 2 is 6. 5 times 2 is 10. 3 times 3 is 9. 5 times 3 is 15. 3 times 4 is 12. 5 times 4 is 20. 3 times 5 is 15. 5 times 5 is 25. So now I have a number of fractions to compare. And I'm probably going to look at these two because I've got 6 of each again, 6 and 6, but now I'm only dividing it into 9 pieces. Now I'm dividing it into 10 pieces, so I know that this number is larger because I've got 6 of them, but the whole item is divided into fewer pieces. There's one more way that I'm going to add, actually, and that is cross multiplication. And again, cross multiplication only works if it is two fractions. It doesn't work if there's more than that. So you have to be careful which strategy you choose depending on whether or not it's 2 that you are working with or 3 or more that you are working with. So for cross multiplication, what we do is we multiply across, just as it says. 2 times 5 is 10. 3 times 3 is 9. So 2/3 is my smaller fraction. The thing with cross multiplying that you have to be careful of is you have to remember that this 3 times 3 attaches to the bottom of that fraction, so the 9 is with this fraction. We have to be careful we don't go the other direction because we're going to end up with the same number. 3 times 3 is 9. We could put the 9 up there, but then it's wrong. It's attached to the wrong fraction. So you really have to be careful with this one to make sure that you're attaching it to the bottom of that fraction. All right, so we're going to do some practice now with each strategy, so we've had some experience with each strategy. Okay, we're going to go back to our Explore section and try some comparing of two fractions using a number of strategies. So let's start with 1/2 and 1/3. Oops, sorry. 1/2 and 1/3. And let's use our number strips strategy. So we need to create two number strips that are the same length. Okay. One needs to be divided in 2 pieces. One needs to be divided in 3 equal pieces. Oh, not so equal. Let me fix that. Okay, a little bit more equal. And I would shade in 1, and I would shade in 1, and I could see that 1/2 is the larger of those two fractions. Let's try 6/12 and 3/4 using circles. Now this is going to be a little tricky because 12ths in a circle might be a little bit much, but I'll give it a try. So in half again. That's 4 pieces, in half again. I don't know that that's going to work. Let's go back. Okay, so in half, and now I need 6 in each half really, so I'm going to work with this half. Oh, this is tricky. Getting those pieces fairly equal is hard. They're not equal. This is where I really don't love this strategy because it's very hard to get those equal sized pieces. I'll try it one more time here. Each section needs to be an equal size. And this gets really tricky. Let's see here. If I had to divide each third or each fourth into 3 pieces, try to do this as best we can into equal sizes. Now they're not quite equal sizes, unfortunately, but it's very hard to do. So I wouldn't always recommend this strategy of using the circles, because as you see, it can be really hard to create. 6 pieces colored in, and I didn't color them all in completely because I want you to see that there's 6 pieces there, and then the next one has to be in fourths, and 3/4 are colored in, and again I want you to be able to see the pieces there, but we can see that more is colored in of the 3/4. So 3/4 is the larger fraction. Alright, let's take a look. Now we're going to use a number line, and I'm actually going to combine a couple of these just to make this a little easier. We're going to go 6/8, 3/4, and I'm going to add let's add the ones with the 8s there, 3/8 and 2/8. So I'm going to take this line. It's going to go from 0 to 1, and because my largest denominator is 8, I have to divide this shape into 8 equal pieces. I find it easiest to take it into 2 halves, then divide that half in half to get the 4 parts. Same thing over here. Okay, so if that's the case now, 3/4, I'm really making it out of 8ths, so I'm going to really multiply by 2 for each side, so it's actually going to be 6/8. Oh, look at that, it's the same thing. So I'm going to count 1, 2, 3, 4, 5, 6/8, which I see now is also 3/4. 3/8 is pretty easy. Let's make this 2/4 just so it's a little bit of a different one to look at. And again, I'm going to have to put it in 8ths, so it's going to be like 4/8, and 2/4 I can actually see is 1/2, so this would be 1/2. So then in comparing, 3/8 would be my smallest fraction, 1/2 or 2/4 would be my middle fraction, and 6/8 and 3/4 would be larger. All right, and now we're going to use equivalent fractions to help us. So we're going to have 6/12 and we're going to have 3/4. Those are the two that we're going to compare. And I'm going to use my multiples. 6 times 2 is 12. 12 times 2 is 24. So that would be an equivalent fraction. I've times by 2 here. And I'm going to go times by 3. 6 times 3 is 18, 12 times 3 is 36, let's try 4, 6 times 4 is 24, 12 times 4 is 48, and you can definitely use your calculator through the entire unit. Just make sure you write down what it is that you've multiplied here. So I've multiplied by 4. Okay, now I'm going to try the same thing with 3/4. 3 times 2, I'm going to go by 2 for both. 3 times 2 is 6. 4 times 2 is 8, and actually I can stop right there because I can compare already because I've got 2 of the same numerator, 6 and 6. One's divided into 12 pieces, one's divided into 8 pieces. Well, if it's only divided into 8 pieces, that means 6 out of 8 is larger, so that would be the greater of the 2 fractions. All right, and lastly I'm going to use cross multiplying. So we're going to go 5/6 and 19/24 here. Remember, you have to be going down, not up. I am going to use my calculator here. 6 times 19 is what I'm doing. 6 times 19 is 114, so 114 on the bottom here. On the other side, I'm going to go 5 times 24. 5 times 24 is 120, and that's on this side, so that means this fraction is the larger of the two. All right, we're going to try question 3 in your practice together. You can use whichever strategy you prefer. Notice though this is 3 fractions, so you have to be careful and use a strategy that will actually allow you to only use 3 fractions to look at. So go ahead and try that now, 3 fractions. You choose whichever strategy you prefer. All right, so we are comparing 1/2, 7/10, and 4/5. It says to use number strips. What the heck? I'm going to use number strips. Okay, so I have to draw 3 of them. They have to be equal in size, or at least length. And now I need to divide them. So one needs to be divided only in half. That one's pretty easy. The other two need to be divided into 10 and 5. Ooh, that's going to be tricky. Let's start with 5 on the bottom there. Okay, those parts are fairly equal. Now 10 is going to be kind of right in the middle of that. Not loving that. They're not 100% equal. Perhaps maybe even using your ruler and making each strip 10 centimeters would be a good idea. And then each centimeter could be your spot that you mark for the 10, and then for 5 it would be every 2 centimeters, and then half would be, well, half of 10, which is 5, which would work quite nicely. All right, so I'm going to color in 1/2. Okay, here I'm going to color in 7/10, and I'm just going to color in the middle bit here so that you know which part's colored, but I'm not going to worry about it too much. And then here I'm going to color in 4/5. And then in this case, 4/5 would be largest, 7/10 would be second, and 1/2 would be smallest. I could use equivalent fractions to help me check this too, because I could say, okay, I'm going to make all of these out of tenths, because look, if I multiply by 5 here, I can make it out of tenths. If I multiply by 2 here, I can make it out of 10. So, all right, if I look at this, 1/2, if I'm multiplying by 5 on both sides, that's going to be 5/10. 7/10 stays as it is. 4/5, I'm multiplying by 2 on both sides. 4 times 2 is 8. 5 times 2 is 10. So really we're looking at 8/10, 7/10, and 5/10, which works quite nicely. So I can use equivalent fractions in this case to compare as well, because there are there's a possible denominator that can be the same for all 3 of them. This concept is quite tricky, so it might take us some time. All right, you're moving on to the concept practice. It is page 172, numbers 2, 5, and 7. Note, again, use whatever strategy you want. You don't have to use what it asks you to use in the question. If you'd like to, you certainly can, but you can use whichever strategies you prefer. Cross-multiplying, equivalent fractions, number lines, paper strips, circles, whichever strategy you find works best for you is just fine. Actually, I'm going to add question 12 as well. So make that 2, 5, 7, and 12 for you to take a look at. All right, and again, here are the text pages in case you forgot your textbook. Taking a look here, 1 to 5, or 1 to 4. And here you have 5 to 8. And lastly, 9, 10, 11, and 12.